Hi folks, welcome to another Wednesday widget from NYC CNC. Today's episode is a little bit different. All we are going to do is take a look at making this slot. Now you might think that's boring, but I'm actually really excited for this because I think it really represents how I've changed as a machinist, and I'm hoping how you guys can change if you haven't already. I get so many emails from folks that are making awesome things with their Tormach, whether they're starting businesses or their own job shops or they're manufacturing, and we're sort of all breaking the rules. And I've talked to a lot of folks lately who are all on the same page, and maybe it's something with our generation, I'm not sure, but we don't care that we aren't trained machinists. We don't care that we don't have apprenticeships or journeymen, and that's not to say that those aren't good things or to disrespect them. And gosh, in sometimes, many respects, I wish I had them, or God, I'd love to go work in a machine shop for 6 months and learn. But we also have the benefit of not being constrained by some of that process and mentality and mindset. But I love the fact that I've earned a lot of respect from the YouTube community about how to make stuff and how to use the Tormach. But you got to remember that doesn't always make me the best machinist. And what I want to talk about today is the before and after. So I used to make this part in now what is clearly a really dumb way. Like seriously, dumb. And I used to take, it's about a 1-to-1 slot. So it's about 350 thou wide, 350 deep. And I used to take a 2-flute, 1/4 inch carbide end mill and go through the middle of the slot. We'll take a look at the cam here in a second. Go all the way down and then clean up the front side and clean up the back side. And I would take baby steps because I would have chip loading, but that meant you're only cutting with the very tip of the tool, which reduces tool life massively, and you're paying for a lot of carbide that you're not using. It's a very slow cycle time, and it's just crummy. And so actually right when I moved to Ohio and I'm really trying to up my game, I thought, wait a minute, there's a better way to do this. So the short version of my iteration to get me where we are today is, okay, I thought, well, let me use 2 different tools. One will be the sort of semi-worn out, and don't make fun of me here either, folks, semi-worn out 1/4 inch end mill. I'll use that for the crummy work, and I'll have the fresh tool will be the final cleanup because it'll be sharp, it'll give a good surface finish, and it'll be dimensionally accurate. And then after a while, the clean, good tool will become the crummier, rougher. It's a terrible idea. You don't want to be using a worn out tool, period. So then I looked into a rougher, and I thought, now we're talking. And for some reason, I love my 1/2 inch rougher, but I never gave smaller diameter roughers enough credit. You know, rougher meaning a corn cob type mill. So I used one of those and had great success, again, just slotting. Then, coincidentally, I had a call with Carl from LakeShore Carbide, actually specifically for this reason. The 1/4 inch corn cob that I have is the one of those coatings that you're not supposed to use on aluminum, and I didn't see on their website, which stinks, but I think Carl said they're working on it. I didn't see a 1/4 inch rougher for aluminum. So I thought, you know, I'll just call him. Nicest guy, ended up having a great conversation. Ends up that he knew the channel, which is really cool. And he pointed me right to the tool. There's a link in the video description. And here it is. It's a 1/4 inch rougher for aluminum. It's a little bit different. It has almost like a chip breaker ground into it instead of the actual wavy corncob flutes. Okay, perfect. Now we've got the right tool. Now let's talk about toolpaths. No more slotting, folks. That's dumb. We've got enough diameter here relative to the tool. Let's use high-speed machining or quasi-high-speed machining. I'm not going to get caught up in semantics on whether it's proper HSM. It works. So with that, folks, let's take a quick look at the cam. We're going to machine it, and what's really cool, we've got some slow motion footage of those of the LakeShore Carbide tooling in action, which I think is awesome. We then use a high-helix, I think that's the correct term, 1/4 inch finishing end mill. This one is from McMaster. I was hoping it was from LakeShore Carbide because I really wanted to promote them because they've been such a great company and customer service is great. But this one is from McMaster. I don't like buying tooling from McMaster. It's expensive and they don't make it, so you end up, I'd rather buy it direct from that company so I can support them or talk to them. But nevertheless, it is a very good surface finish. Anyways, so I'm hoping you guys will get something out of this, in that it's not expensive and there's no reason you can't do this as well. And for the guys out there who are running, small production runs or big production runs, or trying to learn, and again, we don't have that benefit of always being in the production world and having machinists share their secrets with us. And yeah, let's all hope we can get a little bit more chips in the air here. So let's take a quick look at the cam, and then let's head over the mill. Okay, here is the old version, and again, just totally being honest about how I used to do this, because hey, I did. So we were taking it in 5 depth of cut passes, which is about 70 thou each, 5,110 inches a minute, and I think we were stepping it over and then doing it by layers. So if you look, when we ran the simulation, it would cut a slot, and then it would trim a little, so that way on your second pass you're not totally slotting, because you've got a little bit of room to help with chip evacuation, which, if you remember from the video I just posted on chip cooling, or on CNC coolant systems, chip evacuation is huge. So the truth is, this worked. There's nothing wrong with it. It's just amateur and slow. And if we reset, we should get a time out of this. We are looking at like 8 minutes to run a part. So let's open the new file and take a look at it. So here is the new file. First of all, look at these little toolpaths. Pretty cool, right? So we're going to use 2 different tools. The first one is that 1/4 inch LakeShore Carbide, and I'm excited to do this video, but I'm not sure I've pushed it to the total limit yet. I didn't want to break this tool because I only have one right now. I got to order a bunch more, but I'm running 15,116, and how many depth of cut passes? 1. Pretty sweet. We're leaving 15 thou just to clean up with the second tool. So you could argue that is one downside, is you have to do a tool change. Not a big deal, totally worth it. And I'm allowing it to do both. I'll come back to one thing I am having a problem with, and we're doing high-speed cuts. This is that option, and 25% dictates how far in it steps each time. So just take a look at this tool path. I think this stuff's cool. Like, I am so excited to take this a lot further. You can see, there we go, these little, and if you look at it, it's going to chip load kind of as it kind of comes into that semicircle, but it always can get the chip out. I've had no problem running this now for quite a while. Yeah, I keep my coolant line aimed in there, so you've got some air assist, if you will, but we're doing this in one pass, which is awesome. Now, one of the problems I'm having that I need to figure out is I want it to be done here, and I can't get the code to stop coming back. And yes, it's taking a little bit of that material. I'd rather take an extra wider pass going left to right, but this is a total waste of time right here, folks. It's just, I can't figure out the SprutCAM fix for that, so I will let you know when I do. And then it switches the tools, and it just takes that little clearance cut. That is again, that's the current McMaster tool, but I'll find a new version of that at some point. I'm only doing 15,120. Again, I need to experiment how much faster I can go. Of course, only 1 depth of cut, and yeah. So, here, let's look at the cycle time. 4 minutes, so 4 minutes 22 seconds, so about half. But folks, a half of this one, 330, so we should be able to shave half of that off. So we should really be getting this done in like 1:45, which would shave, let's see, a minute, or that one shave 1:45 off. So that whole tool op should come down to less than 3 minutes. So huge savings, and it's a better cut quality, and I don't have to worry about babysitting the machine quite as much, because I'm not worried about a 1/4 inch end mill that's slotting a bunch, kind of getting dull and crappy, and leaving that chip weld on the finish, and getting much better tool life because I'm using a much deeper depth of cut. Such a win. So let's make some chips. All right, part loaded up. Let's rock and roll. Funny, you almost get nervous when you see the tool, for me, go down that far. I like the, as I mentioned, I talked a lot about in the coolant video, I really like the Trico for this setup because I can see the part, and sometimes just seeing gives you the confidence to know it's going okay. You can see how evacuated these chips are getting. They're really getting blown all over the place. Should show up on camera. You can see a tiny bit of that chip weld that was really what plagued me when I was doing it the old way. You would just see that build up all the time. So I think that's okay. We've been running a lot of these parts, both on this specific part and a few other similar parts and similar operations. But maybe I need to adjust, you know, you can adjust how far over it goes each time. And again, I'm only going 16 inches a minute. The high-speed machining that I've seen and folks talk about is really high speed. Much faster than we're doing here with even thinner cuts, but I have no complaints. We're making progress. You're also going to see, though, we know it takes a little bit more of a cut on the way back from right to left, and I don't want to do that because it's a waste of time. And if I can do that wider on the first cut, then obviously I'm creating an even wider channel, which the wider that channel, the easier it's going to be to get the chips out. So I'll fast forward through it coming back here because it's boring, and like I said, I really want to get rid of this, but I haven't figured out how to do that yet in the software. I suppose I could just edit it out in the code, to be honest with you. I hadn't even thought of that for if we do a production run, it'd be worth it. I just put the feed rate override on 299%. That's actually pretty cool. You can get a feel for what high-speed machine is supposed to look like. I'm just trying to get through this quicker. I rarely use feed rate override because when it bites you, it is, I think, one of the worst feelings in the world. Here's that other McMaster for now high-helix cleanup tool. Got a little bit of chip on it. Let's clean it up, and you can see it's a really nice looking tool. I think one of the worst feelings I had lately was I broke a brand new thread mill, again operator error, but it's always tough to see a $50 tool that never cut a single chip. This, actually, you know what, let's try that. Let's go feed rate override. So we're about, or let's do it on the back side. I'll go aggressive, I'll go 250, and we'll see if we can compare the finishes. That's pretty fast. We may see a difference. It's a question of whether it's acceptable. I almost forgot to include this 240 frames a second HD slow motion. How cool is this, folks? Whether it's acceptable. Let's take a look. So if we take a look close up, you can see a little bit of a different surface finish. So when we sped up, it definitely did compromise it. Whether it's still acceptable or not, it's really a call for you. I mean, it's actually pretty darn nice. The ripple is almost more of an aesthetic ripple than it is a physical ripple where someone would think, ooh, that wasn't machined well. But the side that we went at our standard feed rate on, that is nice. So I hope you guys have learned something from that. Don't be intimidated by trying out high-speed machining toolpaths. The goal is really get away from slotting. Get those chips evacuated by letting there be a little bit more room. Use high-quality tools. Again, the LakeShore Carbide, that chip breaker feature and that coated quarter-inch carbide end mill is really awesome. And I love seeing all the folks that have taken their Tormach and made something of it. They're making parts, they're doing Kickstarter businesses, they're running their Tormachs full time now. It is awesome. So for the folks out there like me that don't get to live in a real machine shop and learn from the experts, hopefully this has been helpful. As always, I appreciate you guys watching. I appreciate the likes, the comments, the thumbs up, and sharing this video with your friends. Take care, and I'll see you next Wednesday.